Well, we've got to continue our work into fractions. And so we're going to look at how fractions add. So to do that, I'm going to kind of look at the properties of real numbers that we've been discussing and show how fractions with the same denominator work. And then we're going to use that to expand our ideas to how fractions with different denominators work. So when we mean fractions have the same denominator, they'll look like this. I've cut my things into the same amount of pieces, and I'm adding up how many of those pieces I have. So if I have something cut into B pieces and something else cut into B pieces, if I have A of them and C of them, I can say I have a total of this many pieces of size B. That's mathematically what this says. We can kind of look at this using our properties of real numbers that we've been talking about slowly, and we're slowly kind of developing a list of things that are always true. Well, I can look at this as a combination of multiplications. And my distribution rule, remember distribution says if I have the same thing multiplied on each side, each term, I can pull it out. We used that when we were thinking about collecting like terms. And so I can think of that here. I can pull this out via distribution. And I have the number a plus c. Well, if I multiply the number in parentheses that I've gathered together by the reciprocal, because we can think of this as a plus c over 1, and so I can move from here to here. So all the things we've been learning about numbers says this is true. And if we think of it as the concept of I have parts, and these are cut into the same number of parts, well, I can add up how many of those parts I have. And so that also says it's true. For us, what it means is we can call like fractions the things that are cut into the same number of parts. So if I cut something into 5 parts, and I have 2 of those parts, and I cut something else into 5 parts, and they're the same size, and I have 3 of those, well, all together, I have 5 of this 5-parted thing, or 1 in this case. And so that's the process we do for adding like fractions. So we call these like fractions, and what we're going to do is adding like fractions. And what we'll say is adding like fractions is the same denominator, or the same downstairs. And the same thing can go for subtraction, right? Because subtraction we've defined as addition of the opposite. So when we talk about addition, we get subtraction for free right now. So if I have 3/8 and I add 2/8 to it, well, these are like, so my answer is going to have the denominator of 8, and I add up what's on the top, 5/8. I can even have variables in my denominator. I've cut something into 8 times x parts, and I've got 5 of those. And I'm going to add it to it 1 times 8 times x parts. Well, my denominators are the same, so that's going to come over here, and I can collect the addition on the top, and I've got 6 of those. But notice I have some factors I need to deal with. So 6 is 2 times 3, and 8 is 2 times 2 times 2. So one of the 2's in 2 times 3 is going to go away, and one of the 2's in 2 times 2 times 2 is going away. In other words, I have 3 over 4 times x. And I can do multiple additions. And as long as the denominator is the same, all of these are going to count up how many things I have that have parts of eighths. And so 3 plus 5 is 8. 8 plus 4 is 12. Now this can be simplified. And so let's write out the factors of 12. That's, let's see, 4 times 3, or 2 times 2 times 3, over 2 times 2 times 2. So these groupings of 2 will cancel and I get 3 halves. But that's a whole number, so if we write it as a fixed number, 2 divides into 3 once with a remainder of 1, and I write that over the fraction. So when we add like fractions, we keep the denominator the same. The same thing goes for addition. Now I'm going to take the extra step that your book doesn't do. I'm going to convert my addition or my subtractions to additions. And so I'm going to say this is the same as adding the opposite. I still have a denominator of 9, and I have 8 plus negative 1, which is 7. And let's do another one. I will change this to addition of opposites. And I'm doing this not really because it changes the mathematics. We can still subtract 8 minus 1 is 7, because I want to stress that subtraction and addition are the same thing. And so sometimes when I say addition rules, I'm saying addition and subtraction rules. So I'm just highlighting that addition and subtraction are the same thing, where subtraction is addition of the opposite. So my denominators are the same. I'm going to have 8 in the denominator, and 7 plus negative 5 is 2. But these have shared factors of 2, and so I get 1/4. Now sometimes, having a variable in the numerator of a fraction, we can get a variable expression. Oops. We can get a variable expression to come out. So if I have 3x of something that's cut into 4 parts, and I subtract 7/4 from it, then that's equivalent to subtracting across the top, because I have the same denominator. Now this is a variable expression. I don't have any value for it to simplify until I put something in for x. And this is okay. A really nice thing that will be useful when we do certain algebra problems is that this is also reversible. Because I have 2 terms in the numerator, this doesn't work if they're in the denominator, over a denominator, I can go backwards. I can say that it came from the 2 terms spread out like this. And as we've seen with solving for x, this helps us isolate the x term. There are other ways to deal with that with multiplication. There's more than one pathway to sometimes solve problems. But a lot of the things we do, well, anything with an equal sign, we can go either way on it. And that's one of the patterns that we have here, is that equal signs are bidirectional. Now, a place where fractions come up a lot is in measurements. We will measure things in, let's say, this is 5/12 of an inch, and this is 7/12 of an inch. Right, small little piece of like electronic component that I have measured in inches. Well, if I want to find the perimeter, my perimeter equation is I add up each side. And so this has 2 sides of 5/12 inch. And it has 2 sides of 7/12 inch. Now, all of these have a denominator of 12. So I can take my top 5 plus 5 plus 7 plus 7 because they have the same denominator. It's only true if the denominator is the same. And so I get 24 twelfths. But this is an improper fraction. If I do the division, it's 2 inches to make this small little thing for the perimeter. Well, we can also find the area. The area of a rectangle is the length times the width. And that goes back to what we did previously, that we multiply fractions. We multiply the denominator, which is 144, and we multiply the top, which is 35, and that would be inches squared. So when we multiply a unit by itself, we square it. All right, just wanted to throw that in to some of the geometries we would see. I know it doesn't have to deal with adding the same denominator, but it is something that we might see as we work with different geometries. What we're going to do now is we're going to look at techniques we need to find things that the ways we can simplify or get fractions to have the same denominator. So we're going to come back and we're going to do another kind of subpart of chapter 4, section 4 here, that looks specifically at how we can get common denominators and we can get them as small as possible. So see you on the other video.